Hello class, we are in section 5-4, solving radical equations. So now we're going to talk about solving equations where we see our lovely little radical sign here. Don't panic, I promise it's not that bad. Your first step in these equations is to get that radical sign all by itself. So what we're going to do with this one is we will add 1 to both sides. So we end up with the square root of x plus 5 equals 4. Now, just like we take a square root to get rid of an exponent, we're going to use an exponent to get rid of a square root. So we get x plus 5 equals 16. And then you know what to do with this so that you get x equals 11. Easy enough. Let's look at what we do with 1 with a cubic. So again, we're going to get the radical by itself by subtracting 2 from both sides. We get the cube root of x equals 2. And then to undo a cube root, we cube both sides of the equation, and we get that x is going to be 8 because 2 cubed is 8. So once again, to undo, you're just doing what's called the inverse. So the inverse of a cube root is taking the cube. The cube root of x cubed is just x. These two pieces of this function cancel one another out, just like the square and the square root here cancel one another out. Okay, so now let's go on to example 2. This looks like a really complicated problem. I'm going to tell you a secret. When you're looking at a word problem that has 3,000 words in it, like this one does, see if they give you an equation. This one already gives us an equation, yay raw. And then it tells us that y is the height of the suspension cable. That's a hard word to say. And x is your distance from the middle of the bridge. So then that's all we need to know. Who cares like what we're talking about when it comes to the Golden Gate Bridge? So now we're going to see what the question is asking. It says, how far is the cable from the roadway when you are 200 feet? So you are 200 feet, meaning your position. So y is 200 and x is what your your distance. Sorry, your distance. Your distance is x. I totally screwed this up. Sorry, guys. Your distance is x, and then y is the height of the suspension bridge. I should not have messed that up. So x is 200 in this case. So all we're going to do is take that value and plug it into x in our equation. So we get 200 equals the square root of y minus 220 over that really long decimal. 0.010583. So this is division here. So we're going to multiply both sides by 0.010583, 0.010583, and we get that 2.1166 equals the square root of y minus 220. Now you're panicking because this is a decimal. It doesn't matter that this is a decimal, we still square it the same way. This is why using a calculator is so important. When we square that, we get 4.48 equals y minus 220, and then we will add 220 to both sides. So we get that 224.48 is y, and y is the height of the cable when you are 200 feet from the middle of the bridge. So there is that. Okay, let's move on to example 3. So example 3 deals with finding extraneous solutions. Now, extraneous, the part that you need to worry about this is the extra. So we're looking for the extra solutions that really don't make sense in context. So I'm going to solve this problem. And you get these extraneous solutions when you have more than one x. Okay, so what you're going to do is now you see that that square root is all by itself already on one side of the equation. So since the square root is by itself, we are going to square both sides. So this side is easy. It just becomes 3x minus 2. And then remember that over here, you have to FOIL it. And when we do that, we get x squared minus 8x plus 16. Now, you'll notice that we now have a quadratic over here. So in order to solve a quadratic, everything has to be on the same side. So we're going to subtract 3x from both sides and add 2 to both sides. So that we get 0 over here, because this all cancels, is x squared minus 11x plus 18. Then how do we solve? Well, we factor. So we get 18, 1 and 18, 2 and 9, 3 and 6. And lo and behold, the 2 and 9 add up to 11. So we get x minus 9 and x minus 2 equals 0. So that means that x is going to be, I'm going to write this in a different color, x could be 9 or 2. Well, now we need to decide, okay, do both of these solutions work? So I'm going to plug them back in. So we get 3 times 9 minus 2 equals 9 minus 4. So 3 times 9 is 27. 27 minus 2 is 25. So we have the square root of 25 equals 5. And that is a true statement. So we're going to give it a big old check mark. Then we're going to do the same thing with 2. So we're going to have the square root of 3 times 2 minus 2 equals 9 minus 4. 3 times 2 is 6. 6 minus 2 is 4. The square root of 4 is 2. Well, 2. Haha, it's not 9 if you're plugging in 2. 2 equals negative 2. And this is not true. So with this one, we know that this cannot be a true statement, okay? Now, let me share something with you that's very important. The square root of x, hold on, that's not what I meant. X squared equals 4 has the solution that x could be plus or minus 2. So it has two solutions. When you're taking the square root of a number, the only square root you're looking at is the positive value. So the square root of 4 is only 2. The negative square root of 4 is negative 2. So this is a very important distinction to make. And if you don't understand what I just said, this is something that you will want to ask me about in class. The word that goes here is an extraneous solution. So an extra solution that's derived from the original equation, but is not a solution to the original equation. So like here is where we have, this is our original equation. Well, when we square both sides, we end up with this and this, right? So this blue one represents that left side or right side squared, and the red one is our left side squared. And so then that's why we have extra solutions. So we'll pause here and we will start example 4 in the next video.